Alright, we're getting ready to take a walk through the solar power Connex. This is work in progress. So we're going to go to the very back end and show where everything comes in and then walk through all of it. So right at the moment, here's our power coming in. Alternate energy conduit access, which is our solar and will be our generator access also when I put a generator system in. So just a box to pass through from outside to inside, and on the outside wall there's a wire way out there where everything's coming into it. And from there, some flex down into here. Bag out of the way, where we can see that this is all our DC distribution box down here. And what we have in there, if we open this up, is all our solar fuses up here in holders. And then down below, we've got all our Victron Links products. And I have yet to flip the labels over. I do have the additional labels down there to do. Once I'm done with everything in here, that'll be it. And then we've got our main breaker, which is also a shunt trip. That's a 600 amp, 480 volt breaker. And right now we're set up where everything is paralleled. I've got that jumper plate there paralleling all the battery connections on that big bus plate. So we actually have 1800 amps of current switching available on DC, and that is a AC and DC rated breaker. Coming out of that, up above we have our solar chargers from Victron Energy. Those are the 450 volt, 200 amp per unit output. And those are charging my 48 volt battery bank. So there's 1, 2 slaves, and then the master, same thing. And they sit here rotating through all the different inputs and showing what the total is along with temperature, and down below it shows external control. Directly above that, get this up high enough where we don't have quite so much glare, is network control and all of our communication modules for the solar chargers and the inverters. Solar chargers have Servo GX, and then we've got for the inverters themselves, it's kind of laying on the side where you can't see it too well. Let me go ahead and get that up. And you can see our Schneider inside facility. And we're not using any Wi-Fi on that. We do have the Wi-Fi module. Fiber optic network coming in, so we're totally isolated from anything at the house. There's our fiber connection up there to the network, and then our surge protector, all built in. For fun, we've got a floating light bulb. It sits there and floats and rotates, and I can even, if I hit the right spot, turn the lights on and off as it's sitting there and hovering. And anybody that doesn't believe it's actually hovering, it's just magnetically levitated. Cool thing. Here is our Maple System touchscreen on the front of the PLC cabinet. And in the PLC cabinet, we've got the PLC with my hardened I/O in here. so that anything that is controlling anything is going through interposing relays that can be easily replaced, so we don't short out contacts on any of our controllers or anything like that. And this gives us a screen overview of what's going on in the system. Our charge controls screen, where we can enable, disable stuff and show the states of it, and also turn on our battery charger to the grid or to the generator, and our runtime that we allow on that. And also, if we shut off the solar panels at night, that's turned on right now. So from 7 o'clock at night to 7 o'clock in the morning, contactors drop that out. That's also part of the fast disconnect system, that if there's an emergency, one push button and everything drops out within seconds instead of minutes. They give you a full minute according to the laws to have everything disconnected. This does it in seconds and gives you feedback on everything. Now, it disconnects everything external to this. So when I shut down and kill the output, solars and 120 volt output, or 240 volt output, I should say, this room stays energized until I do a full shutdown on the inverters internally. This is just a contactor for the battery charger for the PLC to turn on and off. And these are the chargers themselves, 2 G4s. They'll put out 100 amps each at 48 volts. Right now I've got them set at 52 volts and 90 amps, so they're not overloaded. The inverter breakers. So these are the standard 3 inverter breakers that we have for our outputs that come with the unit. And then there's the feed for in here, so I can shut off the lights and everything in, including PLC power and everything else. And then there's the built-in feed breakers for the batteries, feeding the inverter that goes to a common bus. We have the Connex 6W Pros inverters. There's 1, 2, and if I back up, we can see this a little bit better. All 3 of them joined together with the backup underneath. And if you look down below, we've got a wireway that's running underneath all this. DC side at that end, a little bit of mix in the middle, and then AC wireway labeled across there. Coming around and up to a shunt trip breaker. Now this is AC. So we've got a 200 amp shunt trip breaker. It will pop at my command, either remotely or in case of emergency. It'll kill itself. Feeding a 200 amp distribution panel. Everything's run through that except for the power in here that bypasses that and goes directly to this breaker panel for this room, feeding all the equipment that's in here that requires 120 volts. From there, we just go out to a 90 with the bellows just because it was convenient. It came with it, so I went ahead and used it. And this external conduit access for 120 volt, and my network cabling is coming in through that. And at the moment, you'll see my network cables hanging, but I've got the conduit to run now, so that'll be done here in the short future. We do have an air conditioner keeping this room cool, and it does have heat. It's a heat pump unit. Right now, this is just my laptop setup, and my PC that actually runs everything is down below here for all the screens that we have. And let's go to screen 1, try to get you a little bit better angle on that. Screen 1, which is our Insight Cloud, showing our AC output and our wattage that we're using, along with all the different reports it has. Next we go to our Batrium setup. Try to get higher again so I can get the glare out. So that's showing for all 160 individual lithium-ion batteries, showing the battery voltage. Right now, the lowest battery is 3.35 volts. The highest battery is 3.36 volts. Now, I do try to keep my cables as equal as I can, but on everything that I do on my batteries themselves, they are run through 1,000 amp bus bars at each end of the battery packs, which I'll show you one right now. So this is saying that our DC bus bar, negative. Let me move my radio. And there's just a quick look. Little isolators on there. Inch standoff, and you can see the thickness of the bar. It's thick. And we can check temperatures on any of this, and it's all room temperature at the highest draw, highest charge. So we have no heat issues, we have no battery voltage issues. Batteries themselves. These are my oldest packs. Those were put in service November 2021. That's part of our Batrium system. For each individual pack of batteries, there's one on this side and one on the back side held up. You can see the column lights are sitting there turned on and doing their thing. Everybody's talking. They're all numbered accordingly, and we do have temperature monitors on all of these in 4 different locations down the battery packs. And the batteries are held together with just straps. I'm not so worried about tension on them as much as I am as far as falling off the edge of my shelves, because they just barely fit in the rack. And this is one of the DeWalt heavy duty storage racks. It's good for, I think, 1,000 pounds per shelf and 7,000 pounds overall. I am going to be going 1 rack higher after I get the rest of this completed. And where my laptop is sitting, there will be another rack of batteries, and then 2 more on top of that, and 2 more on top of this one. But here's a little bit better look of the batteries and how they're constructed. This is 1 pack on this side, this is 1 pack over here on this side. All the battery cables are handmade, hydraulically crimped, heat shrink on them, and they will have covers over all this when done. And I'm probably going to do LED lighting, put clear faces on everything and light them up with probably an RGB LED where I can change colors and make it cute or whatever. Now here, right between the battery packs, is our Batrium system hanging right here. And we've got all our IOs going out of the expansion cards going out through. We've got this hanging out to the side because it is powered through the PLC rack. I've got a 24 volt supply feeding this. So it's not run on 48 volts. It's run on 24 volts like they recommend. And every battery pack has its own 100 amp breaker for disconnect. So this one's got 4 on it. This one over here's got 6. And same type of setup. But all in all, that's the last battery in the last group is number 160. So as I'm going along and looking at anything up here, if it tells me that 3.35 volts, that's my lowest cell, is number 2 right now. So I could go to number 2 and verify the voltage on that. 337, that's 108, 101, and I can go and check those. Okay, so I got 0.02 of a volt difference right now. Sorry about the glare. Now, right at the moment, I am not using my shunt on this because I do not like the one that I bought a couple of years ago. It's just so much smaller than what I want. So I'm using it for voltage only, but no amperage. I'd like to have a shunt like this, okay? Large, massive 1,000 amp shunt, okay? Big bolts to handle my 4/0 cables. But let's walk around to the other side where my DC bus is hooked together. And this is all the ground, the DC negative junctions. And let's open this up. Take a look up in here, and we see how teeny tiny this one is. Now they rated that, but there's no way I can hook 2 4/0 cables to one side of this little sucker and get away with it. So that's not happening. I'm gonna get their other one since now they have a larger version that looks more realistic, because I've got this monstrous bus bar plate in there on isolators for all this. And this is a junction plate coming out of a 480 volt distribution panel, and that's 4,000 amp bus plate. So that's a spare one that I'm going to trim and make a bus to connect all that to hook that shunt in properly where it all looks right and it's hooked up well. Now, as the battery cables exit, I've got these walkover little covers to keep them from getting stomped on and messed up. And that's going all the way around to our DC breaker distribution panel over here. So you can see the positive come up in the bottom and the negative come up around this end. Matter of fact, I left off one thing for you, and that was on my third screen. Sorry about that. Let me go ahead and highlight this. And scroll this up. And that's our Victron solar power chargers and how they're doing. So right now we're at 94%. We're charging at 143 amps. I've got 9,300 watts of solar coming in right now. And that's roughly a third of what I need. So even on a poor day, it will put out everything I need and then some. And then my programming screen for the PLC and my HMI touchscreen, and then my keyboard and everything here for running the PC that runs all these screens, where I can make my modifications and adjustments and tests and reports. And that's it. This thing puts out about 250 amps continuous. It can do double that for 20 seconds. It can do 1.5 times that for 10 minutes. Okay, so 300 amps for 10 minutes for those real high loads that just happen to come in. A couple big ACs kick on at the same time, and along with my air compressor and everything else that this thing's running. But right at the moment, this is running the entire house. my loads will run through it. And thank you for watching.